also during the, oh, recording started. Okay. And also during the use phase of a building where maintenance and repair contribute to the embodied carbon as materials are replaced in particular. Also refrigerants are related to embodied carbon during the use phase. And then finally, at the end of the useful life of a building, greenhouse gas emissions also arise from building demolition and waste processing. Embodied carbon is measured using a method called life cycle assessment, or LCA. Generally speaking, LCA is relatively simple. You take quantities of materials, energy, and other inputs that go into creating a product or a project, and you multiply each of those by emissions factors for those quantities, resulting in an estimate of embodied carbon. Embodied carbon is reported using an impact category called global warming potential, or GWP, which is measured in units of kilograms of carbon dioxide equivalent. And GWP is just one of many environmental impacts that are measured by an LCA, but I'm going to focus on that one today because that's how we measure embodied carbon. In the construction industry, you usually see embodied carbon measured at the scale of a product or a project. So for a product, data typically comes from an EPD. So a manufacturer would pay for a product LCA to represent a specific product, which is then communicated in an EPD. An EPD, or an environmental product declaration, is a standardized third-party verified document that reports the environmental impacts of a product based on a product LCA. So similar to a mileage rating on a car or a nutrition label on food, they help purchasers compare similar products. But in this case, instead of miles per gallon or calories per serving, you're looking at the environmental impacts per unit. And at the scale of a building or infrastructure project, that comes from a sometimes called a whole building LCA or an infrastructure LCA, which is typically led by an architect, engineer, or green building consultant during the design and construction process. And design integrated software can really help automate this, in particular the process of calculating material quantities to input into an LCA, or designers can use a bill of materials from a contractor to do this as well. You can see this sort of at top, the sort of quantities time emissions factors gets you your results. So the environmental emissions factors come from a variety of sources. So that could be databases containing regional averages per material that are built into whole building LCA software or tools. That can be from product-specific EPDs, be from industry average EPDs, from publications like ours called the material baselines. So a range of data sources that are used for those emissions factors. So the reason why we're so focused on embodied carbon is because it comprises a really large portion of global greenhouse gas emissions. Embodied carbon is a huge source globally. It contributes about 17% to global emissions. So that's about 7% for buildings and 10% for infrastructure, which is nearly the size of total building operations, as you can see in this, this pie chart. And emissions from construction materials, a broad view of embodied carbon, like I shared across the life cycle, touches on many different sectors of emissions, but generally the largest source of emissions falls into industrial sector emissions, which is why you see those in yellow here, and the remainder are other industrial emissions. Industry is the largest sector of global end-use greenhouse gas emissions. It's about roughly a third of all greenhouse gas emissions globally, and common construction materials like cement and steel comprise nearly half of this sector's emissions. Plastic and chemicals is another large one as well. And then you have others like aluminum and glass that also contribute. Also, so that's taking a global view, but when you zoom in on a single project, you also see that embodied carbon is really important, especially when we're looking at the shorter sort of the next few decades where we can make a really big difference in terms of climate change. So these charts show the results from a California carbon report we published in 2024, which looks at embodied and operational carbon from 30 new buildings in California. So embodied carbon here is orange and operational carbon is blue. And the left, you see a big spike of embodied carbon right when these buildings are constructed. And then you see in blue the smaller annual emissions from operating these buildings year after year. In this case, those emissions slowly decline due to grid decarbonization efforts in California. You could also do this in other parts of the country where you would expect to see less of a decline, depending on what commitments have been made by utilities. And you also see these spikes at different intervals from material replacement because of tenant improvements or, just having to replace the finishes and at some point enclosure materials of the project. And then finally, at the end, you see a big spike at the end of the buildings, assume 60-year lifespan in this case, when the materials are sent to disposal or recovery. And overall, the cumulative impacts of these buildings, which are shown on the right here, you can see that in 2045, embodied carbon is still over 70% of the total or whole life carbon emissions for the building. And this is, while this study is specific to California buildings, you might expect to have a slightly lower percentage. In Ohio, the message here is still clear that embodied carbon matters, especially in the near term, and we really need to reduce it if we want to meet our climate targets. You can also look at which materials contribute to embodied carbon the most within a building. So this chart is from our whole building LCA benchmarking study, which I'll talk a little bit more about. And it shows the average contribution of different material groups to total ECI, or embodied carbon intensity. On the left, you can see by primary building use. In the middle here is by structural system. And then on the right, this is all projects averaged together, what the contribution is. So in light blue here on the bottom, you have concrete at about 35%. But you can see that that goes up and down a lot depending on the building type and the structural system. Steel on average is about a quarter. So together, those are 60%. Then you see insulation, gypsum, wallboard, and wood are also large contributors. This tracks when you look at U.S. construction more broadly. So this is a recent study we published in August that projects embodied carbon in the United States for infrastructure and new buildings through 2050. So this is the building floor area is based on data from the U.S. government, and then the infrastructure is based on previous material consumption for infrastructure, also from USGS. So this skews a little heavier towards structural materials because it's only cradle-to-grave embodied carbon. So if you remember that chart I showed at the beginning, sort of this is really focused on what are those manufacturing impacts and extraction for materials. But you can still see that, unsurprisingly, concrete here, especially for infrastructure, plays the largest role, with asphalt next at 19% of cumulative emissions, and then blue is steel. And then for new buildings, concrete also plays a role, but a smaller one, so 38%, steel at 24%, insulation at 8%, and aluminum at 6%. And then these are other, this covers structure, enclosure, and interiors. But we know that those only tell a part of the story. Embodied carbon data and modeling continues to improve. We did a different study called the Washington State Carbon Emissions Estimation Study. It takes a really holistic view of carbon in the built environment, looking not only at the typical structure, enclosure, and interiors, but also mechanical equipment, furniture, and taking a whole life cycle stage into account. So construction, as well as all of the use stages and end of life. And so what you can see here is the last slide I showed, where you see projected impacts, and it is looking at buildings and infrastructure and cradle to grave. That is just this dark blue at the bottom. So we think there is also a lot of impacts that go uncounted for because we don't have as common of modeling of those scopes. So you can see here MEP, furniture, and AVIT. This middle section here is additional life cycle stages. And then this really significant part of the top is renovation of existing building stock. So often when you project, here's the new construction that's going to happen, that only takes into account new buildings. But there is an enormous amount of buildings that already exist in the United States, and there will still be continued renovation of those buildings in terms of new finished materials, but also when you have to fix the foundations, when you have to add reinforcement or replace the enclosure of the building. So we're still thinking about what this means, that so much of projected U.S. emissions will come from that. And a last one here on that note, in terms of materials with highest impacts, and this is a separate study that modeled the impacts of the entire European building stock in 2050. And once again, you see concrete and steel at the top, but then because they did include the impacts of renovation projects, you see things like paint is third after concrete and steel, and insulation is fourth. So depending on how much you're taking into account those renovations, you'll see some of those materials show up as really important. And in the US, thinking about the kinds of projects that get built and what that means for where embodied carbon comes from. These are two different charts looking at impacts in the US. So this is from a 10-year period from 2012 to 2023. So on the left here, you can see that about a quarter of projects built in the US are public projects, which is why we see a lot of focus on government procurement policies focused on lower carbon materials, called Buy Clean, or there are other iterations, but Buy Clean is a common name. The public sector purchases about 50% of the cement produced in the US and about 1/5 of the steel produced. So many state governments and also countries around the world are taking a closer look at their purchasing practices to help identify where they can reduce their embodied carbon impacts. And on the right, you can see impacts from the other three-quarters of construction in the US, which is split about evenly between non-residential buildings, multifamily residential, and single-family residential. So obviously, while public sector leadership is really critical, we also need a lot of leadership from real estate and building owners to achieve real reductions. So before I switch gears and talk a little bit about Carbon Leadership Forum, any questions on what I shared so far? Oh, wait, let me see. I see. I see the question in the chat about whether MEP and refrigerants are included. Hopefully I covered that. The answer is some of them include MEP and some don't. So for this study does not include MEP. This is from our benchmarking study, and that's structure enclosure interiors. This one also did not. This one does include an estimate of MEP. So if you want a really holistic estimate, I think our Washington State report does the best job at that in terms of including, we just used data that we don't think is perfect, but we have a low and high end range to show a range of what emissions look like if you have a more holistic view of scope. All right, well, I'll keep going, but feel free to add questions in the chat and I'll stop again after this section. So I'll share a little bit about CLF's work and how we got to where we are today. So in 2009 was the first meeting of the Carbon Leadership Forum in San Francisco. And at this point, the group that gathered and that day described CLF's mission as to drive carbon footprint standards for the built environment. We have a different mission now, but you can see it really started about thinking about measurement and how to drive standards for how to define embodied carbon. 2 years later, CLF was officially hosted at the University of Washington College of Built Environments by the founder, Kate Simonen, who is still our board chair. CLF started to become more recognizable as the organization we are today in 2017. That year, CLF launched the Embodied Carbon Benchmarking Study, which included 1,000 data points representing different buildings, as well as a prioritized list of needs to address gaps in data. The same year, the Embodied Carbon Network, now called the CLF Online Community, was launched, and embodied carbon nerds around the country were using this to share tips and learn from each other on how to measure and reduce embodied carbon. This is a fun time for me. I remember this is a really active community. We still have a CLF Online community today. From the early days, you can also see data and community were both really critical to building and being a part of CLF. In 2019, CLF published its first policy report, the Buy Clean Washington study, beginning our trajectory as a knowledge hub for policymakers in addition to practitioners. And at Greenbuild the same year, the EC3 tool was released, as well as the first version of the CLF material baselines. The EC3 tool was taken on by the new nonprofit Building Transparency later that year. 2019 was also the first NGO government roundtable meeting on embodied carbon, which started with 12 NGOs and today has over 70 active organizations. And in 2020, CLF doubled its staff capacity, which is when I joined CLF instead of a volunteer. And we also published toolkits for policymakers, building owners, and architects, and launched the CLF Regional Hub Network, building off the idea from Anthony Pack in Vancouver. So our first regional hub was CLF Vancouver, which is now CLF British Columbia. And then in 2024, CLF launched as an independent nonprofit organization with a mission to eliminate the embodied carbon in buildings, materials, and infrastructure to create a just and thriving future. Today, we make progress on our mission through 3 general areas of work: building community, like our regional hubs, our NGO government roundtable, and our learning toolkits. We improve data through our advocacy on standards committees, our material baselines reports, our whole building LCA benchmarking study, and other efforts to advocate for actionable, high-quality data to support progress on decarbonization. And we leverage our research and expertise to inform policies that aim to reduce embodied carbon. We have a growing network of CLF regional hubs, primarily in the US and Canada, that advance the mission of reducing embodied carbon in the built environment while being grounded in local communities. This year has been a really busy one. So we had these 6 major publications and several others since April. I think 2 of these are great examples of how our work is really interdependent on our strong network of experts and the regional hubs. So the Embodied Carbon Benchmark Report in blue here is one of many publications from our recent CLF Whole Building LCA Benchmark Study. This is based on 292 buildings that were sourced from 30 architecture firms in CLF's network. The Built Project Case Study Collection, published in April, also includes projects from around the country, all sourced from members of CLF's regional hubs. And these 2 resources, what I call benchmarks and baselines, are some of CLF's flagship publications. So as I mentioned when I was talking about the history of CLF, the first building benchmark study was published in 2017, and then we did a major update in 2025. And this is our 4th version of the material baseline. So we publish that every 2 years. The building benchmark report has low, typical, and high values for 6 building use categories, which you can see here on the right. Again, this is based on buildings in the US and Canada. And one of the big differences between V1 and V2 of this project is that we required really rigorous reporting requirements so that we could feel really confident in publishing these specific of numbers. And because we feel like the data set is comparable because of the work that we put into limiting who could contribute and the amount of data that had to be included when contributing. And everything, including the public data set, is available on our website, and I highly recommend checking it out. There's also an interactive dashboard that is really fun that allows you to explore the data set, so you can filter by lifecycle stage or element or project type, by state, and many other features. So this one is also a great way to explore the data set. The 2025 material baselines is our 4th baseline publication, as I mentioned. So the more recent reports provide baseline values that represent an estimate of industry average greenhouse gas emissions for construction materials manufactured in North America, as well as a snapshot of available data and a methodology for establishing those values. These reports are used in many different ways, and are now, as of LEED v5, are now prescribed as the default baseline value for the new Assess Embodied Carbon Prerequisite and Reduce Embodied Carbon Credit. And this is just a brief snapshot of from one of the summary tables in that report on what the baseline values look like. So you have the product type, the value, declared unit, methodology, and data source notes. So I'll pause again before I share any case studies. Any questions?
So I didn't realize that you guys had the initial SE 2050 challenge. Were you guys also involved at all with the Arch
Yes.
2030 or MEP 2040?
So I was trying not to include everything in the timeline because it was a little long. My colleague Andrew Himes has there's like a long version of this on our website if you're curious. Yeah, in 2018, CLF issued the SE 2050 challenge and helped with some of the initial, as well as the MEP 2040 challenge. We were essentially a home for the challenge before it became a part of ASE SEI. So I think it's a little funny that, there was like a press release where Kate issued the challenge and then the SE 2050 accepted the challenge. But in reality, it looked like there was a lot of members of CLF that were structural engineers that felt like this was something that would really help inspire action with structural engineering firms. I think they were right. It's been really amazing watching SE 2050 grow since 2018. But yes, that was. And then the Architecture 2030 challenge for products, which is not, I would say, as big as their their operational energy challenge, that actually was announced the day that CLF was hosted at University of Washington, which I kind of forgot until I was reading this. And then I cannot remember, I think the MEP 2040 challenge was issued in 2022. So that one also, and then now that is hosted by Architecture 2030. So, if you're familiar with the ECHO project, which is a group of certifications and voluntary commitments. So all of those groups, so AIA, SE 2050, MEP 2040, also ASLA for landscape architects, and Infrastructure 2050, all of those commitments are part of that organization, which CLF currently facilitates. Well, I will share some case studies from our recent report, and then I won't talk about them too much, but I have some slides just on intro resources in case I was curious as y'all get started. So this is from our case study collection we published in April 2025. It has 13 project case studies from around the country, including one in Ohio that I'll share. I will say we're trying to figure out now whether we can make this process into a template that hubs can use. We've already had interest from some of our other hubs of can we publish case studies from projects that we're working on, sort of building off of this template. So something to think about in future years. So in addition to looking for built projects, so the projects had to be built, they had to be complete rather than just designed. And we also wanted to get a range of project types that were across the country. You can see here a little bit, the red dots are the projects that were included. We had a lot more. I think we ended up having 40 projects submitted, but we were only able to publish 13 on the timeline we had from our funders. And then the yellow dots are the regional hubs in the US and Canada. And you can tell that where there were hubs, there was more case studies. So in addition to sort of range of projects, we wanted to see a range of reduction strategies highlighted. So we asked for projects to select whether they use low carbon concrete, material efficiency, mass timber, non-structural bio-based materials, adaptive reuse, material reuse, and low carbon finishes. In reality, most projects used multiple of these. I'd say there are some adaptive reuse projects that really just focused on adaptive reuse, but most projects use multiple strategies. Before I start talking about Pepper Construction, is anyone here from that project team? This is a project in Cincinnati.
Yes, I actually am.
Oh, nice. Okay, well, if I say anything wrong, feel free to jump in.
Okay,
I thought that might happen. So this is a great adaptive reuse project in Cincinnati from Pepper Construction. And Allison, are you from Pepper Construction or someone else on that project team?
Yeah, I am with Pepper Construction.
Okay,
I'm on
great.
our sustainable construction team.
Great. So beautiful project. Some of the highlights were that I think it's really amazing. Sometimes you hear adaptive reuse and you don't know how long whether the building had just turned over. This building was vacant for 20 years, which obviously requires pretty significant restoration and for it to be an adaptive reuse project. The team restored over 25% of the flat brick and 100% of the detailed brickwork, as well as 50% of the original windows. And based on the team highlights and lessons learned, sounds like Pepper Construction was excited to use the available LCA modeling to compare adaptive reuse in new construction scenarios, and also highlighted the huge opportunity for MEP products to catch up with other building materials. And it sounds like, Allison, maybe you are working on this, said that Pepper Construction has been incorporating LCA into projects to develop an internal database of projects across markets and structure types. So as you can see, the efforts resulted in a 64% reduction from a baseline, and this is focused on the shell and enclosure. So the superstructure and enclosure of the building. Most of that is coming from, this is the floor slabs, ceilings, roofing. So basically, mostly from the superstructure. And this is just, we have these for all of the case studies in the publication just to show for the modeling that happened what was included. So this one focused on A1 through A4, B4, and B5, so the replacement of materials and end of life, as well as the superstructure and enclosure, and was done after construction. The next project is called Prologis Nexus. This one is a 267,000 square foot industrial space. This one's in San Leandro, California. I like this one because it's also a retrofit, but it's an industrial retrofit, which you don't hear a lot about. So the original site had 3 existing industrial buildings from different time periods, covering over half the site, and the team was able to reuse the foundation, walls, and a few other features to achieve significant reductions. They needed additional height in some of the spaces, and so they used 6-inch insulated metal panels instead of concrete, which allowed them to extend the height of the wall to build on the existing buildings, and also to not add any additional foundation or wall support that they would have needed if they extended the height with concrete. They also used fiber reinforced type 1 concrete, which allowed them to reduce the volume of the slab from 9 inches to 6 inches, saving on concrete as well as on embodied carbon. And some of the other reductions were using a 30% slag mix in the concrete walls, foundations, and slab on grade, using mass timber for a project mezzanine, and reducing site work embodied carbon through recycled crushed concrete and recycled asphalt pavement. As you can see here, this project achieved a 41% reduction from a baseline. And on the right, you see some of the elements where the biggest reductions came from. So the substructure was really large, that because of reusing the foundations, because obviously foundations, a lot of concrete. So when you reuse them, a lot of embodied carbon savings. And then some other ones from the external walls and facade is another big area, as well as site work over here. This project did pretty comprehensive modeling, so structure, enclosure, interiors, site work, and MEP systems, and modeled during design, development, and construction documentation. I'm also just, because I have them, I'm going to share a few of I really like this Built Environment Plus Embodied Carbon Challenge. So this was a competition in Massachusetts that ran last year. And I can't remember how much money the winners got. I mean, I'm sure it wasn't some enormous amount, but just fun to see the projects that submitted. So this was the Jones Library. So this won the category of renovation and addition, achieving a 30% reduction through building reuse, a hybrid timber CLT structure, flexible program design, and reducing cement used in the project. So in this case, through fly ash. And for the new construction category, the Sustainable Engineering Laboratories won. So they got a 34% reduction through a hybrid steel timber system using DLT. They used polyiso instead of XPS insulation for the roof, and optimized the concrete mix with 50% supplementary cementitious material replacement and Portland limestone cement. And I like this project. I really like this diagram they did on the right. So it shows the cost effectiveness that they found for the strategies they used. So you can see here, for example, that minimizing the below grade construction by shifting mechanical systems to the roof was a huge win for them on both cost and carbon. And optimizing the structural grid to reduce the steel column beam quantities also was a big win-win. And the last one I'll share briefly is this, the People's Choice category for that award. Those awards went to an affordable housing project called Leland House. This project I like, so you can kind of see their graphics. There's a lot going on. But it's fun because they show where they could have gone farther based on what they learned during the project. So in design, they achieved 15% reduction for enclosure, 15% reduction for structure, and 25% for interiors. But they've identified how they could have achieved 26, 33, and 30% respectively instead, with the strategies that they learned through this process but weren't able to achieve on this project. And I think this type of lessons learned from project to project is super critical. No one's gonna, get it perfect on the first time. And I think this really is, for firms that start to do this work, every project is an opportunity to improve. So with that, I'll just share a few slides of resources. So I already sent these slides to Chad so we can share these. All these have links on them. So some of our 101 resources. So we got a fact sheet, a video training series that has sort of 5 to 10 minute videos, a toolkit for architects, a embodied carbon toolkit for building owners, This one is some of our 101 resources. So building LCA 101, EPD 101, as well as the LCA practice guide that was published in 2018. And then I'd say these are three of our top resources for practitioners that get a little more into the weeds. So I already talked about the material baselines and benchmark report. Also really recommend our model embodied carbon specifications. So those were developed with Washington State for their Buy Clean, Buy Fair, but they're applicable everywhere. So they incorporate project requirements for EPDs and for global warming potential limits for concrete, steel, and wood products that could be plugged right into specifications. All right, so that I will stop talking and turn off my screen for now, and happy to answer questions or talk about whatever you all like.
I had two questions. So one, for the existing buildings,
Mhm.
where does that baseline come from? Was that from the carbon intensity on a building scale, or was it looking at kind of here's the material we saved,
Yeah.
here's what it would have been new?
Yeah, so I think for the baseline building is described in all the case studies. There's a section on how they define the baseline. So I don't have it memorized off the top of my head. But for the industrial project, they compared it to typical tilt-up concrete. So you would now use tilt-up concrete, not be built the way that that industrial older facility was built. And for Pepper, I believe was compared as if the building was constructed new. Let me see if I can pull it up really quick. And Alton, feel free to jump in if you worked on that project and already know.
Yeah, it was compared to a new build.
And did that new build, was it more of like a carbon intensity based on the square footage, or was it a design team put something together and measured it?
I think it was design team put
Okay,
a baseline together.
very cool. And then my other
Yeah.
question, I don't know how much you've looked at the results from the new baselines, but was there anything that stood out?
The North American material baselines?
The one with the 292 buildings looking
Oh,
at
the
different,
benchmarking study.
yeah.
So many things. What? Also, I'll pull up the Benchmark Explorer since we have some time, because it's a fun way to explore the data set. So let's see. So as you can see, these are the, actually, I don't have the pulled up. Actually, maybe it's in the homepage, the how to read a box plot. I'm very used to reading these now, but I didn't used to be used to reading them. So basically, box plot. So the quartile one, so this would be 25% of the data set falls below this value. Quartile 3, 75% falls below this value. So you see the box in the middle that's highlighted is basically 50% of the data points are within this range. And so you have the mean average, so that would be average, and then median, which is just the midpoint of the data set. So then if you're looking at, I think, so things that stood out, one of the things that stands out is, let me see if I can pull it up really quick, is by structural type, not IBC type. Well, okay, I'll start with building use. So we don't show the tables that are published in this report. So the one here, we have two different parts of this report. So the first part of the report is what we call embodied carbon budgets, and these are what we say is policy ready. So meaning that we're comfortable with LEED referencing these numbers. And part of the reason you'll see here is that there is less use types. So we have done the analysis to make sure that there's enough buildings in that building use type and to have a standalone number, and that we feel like there's enough of a reason to differentiate between those different building use types. So if you look at it though, really warehouse and storage is significantly different. So, you know, the 400 for an A through C value with A5 is significantly lower than public assembly at 740. Multifamily residential is also, it has a very different ECI. But you see education, office, and public assembly are grouped together. As we get more buildings for any of these, as we get more buildings, we would like to continue doing collection in the future. I don't know when we'll start that. We may start to see differences based on building height or other factors, but right now, building use type is the number one way that we actually see some of those differences that make meaningful differences between I'm trying to think about the best way to say it. Basically, when we did data collection, we thought we would find that other things were really important for understanding the expected embodied carbon range of a building. And we did not find that. So we thought maybe seismic, you would expect seismic to make a big difference, but in our data set, it didn't. You had lower carbon and higher carbon by seismic. It wasn't always consistently correlated or consistent that all buildings in certain seismic design were a certain amount higher embodied carbon. Same for number of stories and building height. So as we get more data, we may publish other official embodied carbon budgets, but for right now, they're just by building use type. Another thing that's interesting, and I'll see if I can pull it up, is the structural system. Yeah, let's see. So you would not expect to see so much overlap between concrete, steel masonry, steel concrete, and mass timber. But so you see a big range of projects or a big range in embodied carbon for all these different structural steel system types, other than wood, light frame wood. And that's why multifamily residential in general is just much lower, is because a lot of light frame wood construction. But with these other ones, it doesn't mean that if you switch from a concrete building to a hybrid, steel mass timber, yes, you will probably see a big reduction for an individual project. But what this means to me is that all of these have a huge range of reduction potential. So if you're building a concrete building, there's a huge range. You can go from the 75th to the 25th. That is still within the structural system type of concrete. And I think some people get stuck on the idea that they can only have a low carbon building if they're doing it with a certain material. And I think this data set shows a really big range for all structural system types and a lot of opportunity for improvement across all of them. And also that light frame wood is really low carbon just because it's a really light material. It's not surprising, but it does stand out in the data set. So those are some of the ones that come to mind. What about you, Chad? Have you spent time with the data set or others? I'm curious to hear what stood out to people.
I've just started getting into it, and similar things stood out. Actually, I was surprised by the mass timber, one, the huge range, and two, the fact that it was relatively aligned with the concrete and steel. I'm assuming we ignored biogenic carbon in those studies.
Biogenic carbon is excluded. Yeah.
Okay. So that is super interesting.
Yep.
I have a quick question.
Mhm.
So you're talking about this data set. Do you coordinate with other groups like SC 2050 on collecting data, and do you use the same data or is it different?
Yeah, so this is a different data set than SC 2050's. I mentioned it, so I will briefly pull up the website for ECHO. So the ECHO project has these organizations. We actually okay, great. The logos are already updated. BREEAM, the International Institute for Sustainable Labs, and Builders for Climate Action just joined like a week or two ago. But one of the reasons, so basically all the organizations that are in ECHO collect embodied carbon data. So CLF collects embodied carbon data through our benchmarking study. SC 2050 collects data into their embodied carbon database. MEP 2040 is starting to collect. So all these different organizations are collecting data. And ECHO came together to try to better coordinate that data so that in the future we could actually have sort of one big data set. Right now, there are differences in the way that we collect data, and that's one of the main things that CLF is constantly working on, is trying to improve that. So one of the first things that ECHO put together is this reporting schema, which is basically if you have a database using the same names in all the fields in the database, so that if I were to download if SC 2050 and CLF both adopt this schema, which we are, then in the future, you'd be able to download both data sets and look at them together, where you'd be able to basically find the commonality between them and be able to compare those numbers. Same with LEAD. LEAD is USGBC has been a really big member of ECHO, and right now they're working on updating the input into, so when you submit a LEAD project, so that you're submitting data in a way that we would be able to look at that data against other data sets like CLFs or like SC 2050s. So really short answer is in the past, no. So some CLF staff members have participated in analysis of SC 2050's data set, but they're different numbers, different buildings.
Okay. So, I mean, in the future, the goal though is to be coordinated. So if I submit data to SC 2050, I could also, it would be similar enough. I could either submit to CLF or they would be able to get the
Yes.
data and share
Our
it.
dream would be
Okay.
to have one big database,
Yes,
and then
yeah.
there'd be different like
Right.
export forms so that your life would be
Yeah.
easier and you could submit it once. That would be the dream. And we're making progress towards the dream, but we haven't launched it yet.
Awesome. Thanks.
Are there any other questions for Meghan?
Can I ask you a question?
Yeah.
I'm just curious what brings people to this group. So what are the main things that are, happening in your projects or your work that made you want to gather with other people in Ohio and talk about embodied carbon?
I'll let others answer.
Well, for myself, it's simply the specifications coming down, clients, owners, everybody's looking towards embodied carbon. I've been working on this myself for 7 or 8 years now, trying to lower our carbon footprints. But that's the real reason for me being involved, so I can see it from the top down and hopefully help from the bottom up of the project. Me being on a supplier end rather than a design end, so hopefully we can work from both directions to build something reasonable and sustainable going forward, and not trip over ourselves. And on both ends, once again, over under design, same way on both ends of us. I think it's a contribution for all of us need to be involved in from the very bottom to the top. So I think it's important for all of us to be involved.
Yeah. What kind of material do you work with?
Oh, I'm sorry. Scott Workman, Soda Ready Mix Concrete Industry.
Oh,
I'm a
great.
concrete
Okay.
producer.
Yeah.
I know for me personally, so I'm in Columbus, Ohio, and I go to the Design Columbus conferences every year. It's more of a LEED specific conference for getting credits for that certification. And I've been to that conference for probably the past 10 years, and it's historically been more architectural, mechanical, more operational side of things, which is LEED usually does with the certifications. And I am lead green associate, but I think over time and just with exposure and gaining knowledge about embodied carbon and how it's kind of now interwoven with design, and then even I think this past year I did see 2 or 3 times in the 2 or 3 sessions at the specific Design Columbus conference, they were talking about embodied carbon and architects specifically mentioning embodied carbon and really reaching out to structurals, such as myself, and really having a conversation about it. So it's kind of like really waiting for like this moment of like we're all talking about the same thing, we're all trying to do the same thing and really create a better product and a better building for our world. So yeah, it's exciting. As well as like Laura, who had a question before, me and her work on we are the chair of the Sustainable Design Committee through the Structural Engineering Association of Ohio. So we're always trying to get people more information about specifically structural, but we still talk to other people on these calls too about how we can collaborate and what's your side and perspective, and then how do we come together. And CLF is great collaborated in that. So yeah, I'm excited to see where the conversations take us.
Great.
Can you hear me?
Mm-hmm.
So I'm with Turner Construction. I'm our regional sustainability manager based in Columbus. And so I've had the opportunity to work with Scott to try and pilot some low carbon concrete on our projects. And embodied carbon is a big thing that is being taken into consideration for a number of our projects, especially for some of our clients now. So for me, it's having this avenue to be able to learn more for myself, but then also to help foster some of those relationships and partnerships to see what we can do and really push it here in Ohio.
That's great. I've met some of your colleagues on the lead materials tag. Gosh, lots of Turner folks.
Yes, we are everywhere.
And so I guess with all that said, for this thing to really work and to reach the potential that I think we have here in Ohio, I think it's definitely important that we have people from across the board. So it's awesome that we just heard from a supplier, a structural engineer, and a contractor. And I hope that we continue to bring people from all these different aspects of the industry together to have this conversation. Ultimately, I would love to see more owners again on this call and more policy makers and just people throughout the state. So again, encourage people to reach out to colleagues or people on projects, invite them to future stuff. The goal is to do this the third Tuesday of every month. So the next invite you see hopefully has all those dates and you can just get it on your calendar for the foreseeable future. And if you guys have ideas for topics or speakers, please reach out to any of the co-leads. Do we have an email, Brian?
Oh, I'm sure we do.
I think there's an email that
We have
will
a
hopefully
website.
that we'll put on the website. So go to the website, email us if you have any ideas, and then we will continue to get these. And then eventually, hopefully, I meet you all in person as we start doing in-person stuff. So, Megan, thank you. I think this was awesome. And believe it or not, I think this was probably the first time for some people on the call hearing this message and how important embodied carbon is. So please spread that word to others that you work with. And hopefully we have Megan back in the future to talk to a group twice as big.
Happy to join again. It was really nice to meet all y'all, and thanks for having me.
So thanks everybody, and I will see you guys later.
Thank you.
Thank you.